Welcome back. Let's learn about the three-dimensional coordinate system. Alright, so far in math, you have been primarily working within the two-dimensional coordinate system. But as you're probably aware, we live in a three-dimensional world. We don't just live in two dimensions, we live in three-dimensional space. And so naturally it makes sense that at some point in math, we are going to be interested in extending our knowledge into the third dimension with a three-dimensional coordinate system. And this is where we're going to spend the majority of Calculus 3. We're going to be working within three dimensions, but before we can actually work with any calculus concepts in 3D, we have to build a foundation of basic knowledge of a three-dimensional coordinate system. Okay, and so that's the focus of this video. And we'll start by talking about what the 3D coordinate system looks like. And to do that, we have to start by briefly reviewing the two-dimensional coordinate system right here. All right, so this is basic algebra stuff, but I think reviewing it is going to be helpful as I introduce you to the three-dimensional coordinate system. All right, so it's going to be good to review some of the terminology and the basic components of the two-dimensional coordinate system. All right, so let's get started. When you work in the two-dimensional coordinate system, remember that you have two axes. You have the x-axis and the y-axis. The x values to the right of the y-axis are the positive x values, and the x values to the left of the y-axis are the negative x values. In the same way, the y values above the x-axis are the positive y values, and the y values below the x-axis are the negative y values. All right, and so you can see that I have that labeled in this coordinate system. Now together, the x and y axis form what we call the xy plane. And the xy plane is the only plane that we work with in two dimensions. All right, we only have two axes, and so the only plane that there is to work with is the plane formed by those two axes, the xy plane. And the xy plane is divided into four quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and then this is the fourth quadrant. Okay, and within the four quadrants of the xy plane, we can plot some points. And our points look like this. They are represented by two coordinates. One is the x coordinate and the other is the y coordinate. We call these points ordered pairs. We have a pair of coordinates that are in a specific order of x and then y. All right, and so when we plot points in the first quadrant, the x-coordinate is positive and the y-coordinate is positive. When we plot points in the second quadrant, the x-coordinates are negative and the y-coordinates are positive. When we plot points in the third quadrant, both the x and the y-coordinates are negative. And then when we plot points in the fourth quadrant, the x-coordinate is positive, but the y-coordinate is negative. So for example, let's say we wanted to plot a point A, which is at the point 1, 2. What we would do is start at the origin and measure the x-coordinate and then the y-coordinate. So we move 1 in the x direction and then 2 in the y direction. So this point right here would be point A. It is the point 1, 2. All right, and then one more thing I want to mention about the two-dimensional coordinate system is when you have equations like x equals 3 or y equals 4, those equations represent lines, right? X equals 3 is the line that passes through x equals 3 along the x-axis and extends forever in both directions. No matter what the y value is for points along that line, the x value will always be 3. In the same way, y equals 4 is a line that passes through 4 along the y-axis, and no matter what the x value is for any points along that line, the y value will always be 4, and that line extends in both directions forever. All right, so that's a good refresher on what the two-dimensional coordinate system is and how it works. And so keeping all of this in mind, we're now going to extend our coordinate system to a third dimension. And so how do we do that? Well, what we're going to do is imagine that you're holding the xy plane like it's a piece of paper, right? You're holding it upright in your hands. What you're going to do is then flatten it. You're going to take the plane and drop it down. So that's going to look something like this. All right, as you can see, we took the xy plane and flattened it. We dropped it so that it's parallel to the ground. Now I have it angled a little bit, and there's a reason for that, which is because now what we're going to do is introduce a third axis. we're going to be able to move outside of the xy plane. Instead of just working in two dimensions where we have an x-coordinate and a y-coordinate, now we're going to have a third coordinate that corresponds to another axis that will allow us to move up or down. And so that's going to be the z-axis, which will be perpendicular to both the x-axis and the y-axis. And it looks like this. All right, we have our positive z values above the xy plane and our negative z values below the xy plane. And so combining the z-axis, the y-axis, and the x-axis together, we form the three-dimensional coordinate system. And more specifically, the version I have drawn here is what we call the right-handed 3D system, because I have the x-axis as the axis that's coming toward me and moving away from me. All right, there is another way to draw the 3D coordinate system where you swap the x and y axes from how I have them here, but that's pretty uncommon. That's called the left-handed system, but it's going to be more common for you to encounter a right-handed system, and so that's what I'm going to use pretty much exclusively throughout all of my Calculus 3 videos, including this one. All right, I'm pretty much always going to draw the x-axis this way and the y-axis this way. Okay, but putting that aside, because we have three axes instead of just two, we no longer just have one plane in the three-dimensional coordinate system, right? We still have the xy plane, but now we have other planes as well. The x and y axis create the xy plane, but then the x and z axis will create an xz plane, and the y and z axis will create a yz plane. All right, and so we have three planes in the three-dimensional coordinate system. The xy, which looks like this, right? It's the plane formed by the x and y axis. Then we also have the xz plane, which looks like this. It's the plane formed by the x and z axis. And then there's the yz plane, which looks like this. It's the plane formed by the y and z axis. It looks pretty similar to the xy plane in two dimensions, right? It's the plane straight in front of you. But now if we put all three planes together, you get something that looks like this. And I hope this picture is a helpful visual for you. I hope you can distinctly see the three different planes that we have here. The xy plane is that red plane, the xz plane is the green plane, and the yz plane is this blue plane. Okay, and so these three planes make up the three-dimensional coordinate system. But now, just like the two-dimensional coordinate system, where the xy plane was divided up into 4 quadrants, we can also divide up the space in a three-dimensional coordinate system. In particular, because of the three different planes, the three-dimensional coordinate system is divided into what we call 8 octants. All right, but now it's kind of difficult to label the 8 octants in this image I have here, so I'll have another drawing that I'll show you in just a second, but before we look at that, I just want to establish how we work with points in the three-dimensional coordinate system. And so I'm going to remove these 3 planes. I believe I might have mentioned this earlier, but when we work with points in the three-dimensional coordinate system, we're no longer going to be able to express points with just an x and y coordinate. Instead, we now will need points that have an x and y coordinate as well as a third coordinate, which is the z coordinate, the coordinate that describes where we are along the z-axis. And so points in 3 dimensions look like this. They are what we call ordered triples. We have 3 coordinates that are ordered with x, then y, and then z. We have the x coordinate, the y coordinate, and the z coordinate. All right, so keeping this in mind, let's take a look at another picture of the three-dimensional coordinate system so that I can show you the 8 octants and what the sign of each of the coordinates will be in each of those octants. All right, so here's our three-dimensional coordinate system, but now it looks a little bit different here. We still have our z-axis moving up and down, our y-axis moving left to right, and our x-axis moving in and out. Okay, but as you can see, I have this cube sort of drawn here to represent our 8 octants. Because of the 3 planes in the three-dimensional coordinate system, we have 8 different octants that we can work within. And we start with the first octant right here, where every single coordinate is positive, right? We're in the positive x direction, the positive y direction, and the positive z direction. So if you plot a point in the first octant here, the x, y, and z coordinates will be positive. Then next to that is the second octant, And this is where points will have a positive x coordinate, a negative y coordinate, and then a positive z coordinate. And then behind that, we have the third octant, and this is where both the x and y coordinates are negative, but then the z coordinate is still positive. And then next to that, but behind the first octant, is the fourth octant, and the fourth octant is where the x coordinate is negative, but then the y and z coordinates are positive. All right, so now if you notice, for these four octants right here, above the xy plane, all the z coordinates are positive. But now for the other four octants, the z coordinate will be negative because we're going to be below the xy plane. All right, and so starting below the first octant, we have the fifth octant, where both the x and y coordinates are positive, but then of course the z coordinate is negative, as we just discussed. Next to that, and below the second octant, is the sixth octant, where the x coordinate is positive, but then the y and z coordinates are negative. And then behind that octant, and you can't really see it the way I have this picture drawn, it's pretty difficult to draw the three-dimensional coordinate system such that you can see all 8 octants easily. Just by the nature of trying to draw three-dimensional objects on a 2D surface or a 2D screen like I'm doing here, one of the octants is going to unfortunately be hidden. In this case, that is the 7th octant, where all 3 coordinates are negative. The x, y, and z coordinates are all negative. All right, so you can't really see that octant the way I have this drawn, but it would be behind the 6th octant and below the 3rd octant. All right, so it's somewhere back there that we can't see. Okay, and then finally, next to that hidden octant that you can't see is the 8th octant that is below the 4th and next to the 5th, and that is where the x coordinate is negative, the y coordinate is positive, and the z coordinate is negative. Okay, so those are the 8 octants of the three-dimensional coordinate system. But now let's take a closer look into how we will actually go about plotting points in this 3D coordinate system. Okay, so when we plotted points in 2 dimensions, it was pretty simple, right? We just had an x coordinate and a y coordinate. So we just measured the x coordinate and then we measured the y, and there's our point. But it gets a little bit more complicated in 3 dimensions because now we have a third coordinate, right? The z coordinate. And so let's take a look at an example point here. Let's say we wanted to plot a point A, which is at the coordinates 1, 2, 3. All right, how would we go about plotting this point? Well, it's going to start out very similar to how we plot points in 2D. We'll start by looking at the x and y coordinates. Just remember that the location of the x and y axes are a little bit different. And so if we have an x coordinate of 1 and a y coordinate of 2, if we start at the origin, we'll move 1 in the positive x direction, and then we'll move 2 in the positive y direction. Now here's where you have to be careful, because you might be tempted to just put the point right here, right? That lines up with x equals 1 and y equals 2. However, if we want to be accurate about how we plot these points, we have to do something a little bit different here. What we want to do is draw some lines that are parallel to our axes. And here's what I mean by that. Let's start with our x coordinate of 1. That's going to be in line with x equals 1 along the x-axis. So what we're going to do is draw a line through x equals 1 that is parallel to our y-axis. All right, so that's going to look like this. Now for the y coordinate of 2, we're going to draw a line through the y value of 2 that is parallel to the x-axis. So that will look something like this. All right, and so where those two lines meet is the location of the point with that x and y coordinate. However, we're not done yet. That's not where our point is going to be because we also have a z coordinate. And so once again, you might be tempted to just move up to z equals 3 right here, right? 1, 2, 3, that would be z equals 3. But if you did that, that wouldn't quite be right. What you have to do is draw another line. And here's how I recommend you go about that. What you want to do is first draw a line from the origin to that point where your lines intersected for the x and y coordinates, right? So I'm going to draw a line to that point right there from the origin. And then whatever that line is, you want to draw a line parallel to that from the value of z that corresponds to your z coordinate. In this case, z equals 3. So if we go to z equals 3 right here, we will draw a line parallel to that line that we just drew down here. And then wherever that would intersect with a line coming straight up from our intersection from earlier, that's where the point will be. I know it seems a little complicated at first, but it's really not too bad once you get used to it. You have to practice a lot. But what we'll do from this point right here, that is the intersection of this line and this line, is we will go directly up to this line, and then where they meet is where the point A will be located. That will be point A. That is the point 1, 2, 3. Okay, so I hope that makes sense. Let me just review that process one more time. You draw a line through the x value for your x coordinate that is parallel to the y-axis. Then you draw a line through the y value for your y coordinate that is parallel to the x-axis. And then you draw a line from the origin to the intersection, and whatever that line is, you want to draw a line parallel to that from the respective z value for your coordinate. And then wherever that line intersects with a line coming straight up or straight down if you have a negative z value from that intersection from earlier, that is where your point will be. All right, now if you're still a little confused, if that's still a confusing process to you, don't worry. I'm going to show you another example in just a second. We're going to work on plotting a whole bunch of points within the 3D coordinate system. But one more thing I want to mention about the 3D coordinate system is how we deal with equations like x equals 3 and y equals 4. And in fact, we can also have another type of equation where we have z equal to some number as well. And so when we have equations like x equals 3, y equals 4, or z equals 2, those no longer represent lines because we're not working in a two-dimensional system. They now represent planes because we're in a three-dimensional system. All right, so x equals 3 represents a plane that cuts through the value of x equals 3 and extends forever in the z and y directions. All right, so no matter what the z coordinate is and no matter what the y coordinate is, the x coordinate will always be 3, and so you just have a plane that extends forever from that value of x equals 3. In the same way, y equals 4 is a plane that cuts through the value of 4 along the y-axis. No matter what the x coordinate is or the z coordinate, the y coordinate is always 4, and so you have a plane along that value that extends in the z direction and x direction forever. All right, and then one more time, z equals 2 represents a plane that cuts through the z-axis at the value of 2 and extends forever in the x and y directions. Okay, no matter what the x and y values are, the z value will always be 2. Okay, so that's the basic introduction to the three-dimensional coordinate system, but now let's practice plotting some points within the 3D coordinate system with an example problem. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful and you want access to more content such as exclusive bonus videos and dark mode versions of my videos, I'd invite you to check out my membership site, JK Math Plus, where all of that content is available. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. All right, so now let's get some practice plotting points in the 3D coordinate system. Here we have an example where we want to plot the following points in the 3D coordinate system, and we have the points A, B, C, D, E, F, G, and H. All right, and so let's start with point A. Point A is pretty simple. It is the point 0, 0, 0, which is the same as the origin. All right, of course, the origin is where the three axes meet, which is right here in the center. So point A is this point right here. That's going to be point A. All right, now let's look at point B. Point B is the point 1, 0, 0. So what this is telling us is that the x-coordinate is 1, but then the y and z coordinates are 0. And so to plot point B, all we have to do is measure 1 in the positive x direction. And so if we go to our origin, 1 in the positive x direction takes us right here. And then since the y and z coordinates are just 0, we don't move anywhere in the y direction or z direction, so we stay at that point right there. And so that is going to be point B. All right, now let's look at point C. We have the point 0, 2, 0. This is similar to point B, except now the x and z coordinates are 0, but the y coordinate is 2. So we only have a y coordinate here, which means we're only going to be measuring our point in the y direction. All right, so if we start at the origin, we have an x-coordinate of 0, so we're not going to move anywhere in the x direction, but we do have a y-coordinate of 2, so we'll move 1, 2, and then the z-coordinate is 0, so we don't move up or down, so we stay right there at y equals 2. And so that will be point C. Okay, now let's move on to point D. Point D is the point 0, 0, negative 3. And so once again, this is very similar to points B and C, except now the x and y coordinates are 0, and the z coordinate is not. It's negative 3. So if we're going to plot this point, we'll start at the origin. We don't move anywhere in the x or y direction because both of those coordinates are 0, but then we have negative 3 in the z direction, so we move 1, 2, 3 below the xy plane or down along the z-axis. So this point right here will be point D. Okay, and now before we move on to the next couple points, what I want you to take away from these 3 points here, B, C, and D, is what the x, y, and z coordinates actually represent. While they do tell you how far along the x, y, or z axis you are, another way that you could think about it is that the x coordinate is a measurement of the distance from the y, z plane, right? This measurement of 1 is how far away we are from the y, z plane. In the same way, the y coordinate is the distance or the measurement from the x, z plane, right? How far away are we from the x and z axes? And then once again, in the same way, the z-coordinate is a distance or a measurement from the xy plane, right? The xy plane cuts through z equals 0, and so the z-coordinate tells us how far below or how far above that xy plane we are. All right, so hopefully that's a little bit helpful in visualizing what the x, y, and z coordinates represent. Really, they are just measurements from the plane that doesn't include that variable. All right, the z-coordinate is the distance from the xy plane, doesn't have z in it. The y-coordinate is the distance from the xz plane, doesn't have y in it. And the x-coordinate is the distance from the yz plane. That plane doesn't have x in it. All right, so that's just another way to think about what the coordinates represent. But anyway, let's move on to our next point, which is point E. Point E is at the coordinates 1, 2, 0. So we don't have a z-coordinate, which means we're only going to be in the xy plane. So let's work on plotting this. We're going to start at the origin. We're going to move 1 in the x direction and 2 in the y direction. So we'll move 1 and then 2 in the y direction. Now this is very similar to that first point that we plotted earlier, except now the z-coordinate is just 0. And so if we want to plot this point at 1, 2, we need to draw those parallel lines, and then wherever they intersect is where our point is. All right, so what we're going to do is draw a line parallel to the y-axis that crosses through x equals 1 for our coordinate of 1. All right, so that will look like this. And then we're going to draw a line parallel to the x-axis that goes through y equals 2 for our coordinate of 2. All right, and so that will look like this. And now where those two lines meet is where our point 1, 2, 0 will be, right? We don't need to move up or down in the z direction. So that right there is point E. Okay, let's move on to point F. Point F is at the point negative 2, 0, 1. So we don't move anywhere in the y direction, but we do have an x and z coordinate to account for. And so we're going to be in the xz plane. So if we start at the origin, we're moving negative 2 in the x direction, and then positive 1 in the z direction. All right, so once again, we're going to need to draw some lines here. We first want to draw a line through negative 2 along the x-axis that is parallel to the z-axis, right? So that will look like this. That's a line through x equals negative 2 that's parallel to the z-axis. And then we'll draw a line through z equals 1 that's parallel to the x-axis. And so that will look like that. And so where those two lines intersect is where our point F will be. That's point F. All right, so since we didn't have a y-coordinate, we could just draw some lines parallel to our x and z axis that cross through the respective x and z coordinates. All right, we have one more example of a point like that with point G. This time we have an x-coordinate of 0, but then we have a y-coordinate of negative 1 and a z-coordinate of positive 2. In this case, since the x-coordinate is 0, we're not going to be moving in the x direction. We're going to be within the y-z plane. And so we're going to move -1 in the y direction and +2 in the z direction. So if we go to our origin here, -1 in the y direction takes us here, and then +2 in the z direction takes us here. Now you could actually just plot the point right there in this case, because if we draw our parallel lines, let's draw a line parallel to the z-axis through y equals -1, and then let's draw another line parallel to the y-axis through z equals 2. You can see that those lines intersect right at this point right here, which is x equals 0, y equals -1, and z equals 2. All right, so since the x-coordinate was 0, that made finding point G a lot easier. We just move along the y-axis and then along the z-axis to get to our point. All right, now we have one more point left, and I know that this coordinate system is starting to look like a mess with all of these different points plotted, but we only have one more to go, and that is the point H, which is at the coordinates 3, -2, and then 1. So now this point has all three coordinates. None of them are 0, so this one is going to be a little bit trickier and more like that first point that we graphed towards the beginning of the lesson. All right, and so what we're going to do to plot this point is draw parallel lines through the x value of 3 and the y value of -2. So let's start with that. The x value of 3 is right here, so what we want to do is draw a line through that value that is parallel to the y-axis. All right, so that will look like this. Then we want to draw another line that's going to be parallel to the x-axis that goes through y equals -2. So y equals -2 is right here. That's along the y-axis. And now we'll draw a line through that value that is parallel to the x-axis. All right, and so those two lines intersect right here, but that's not where our point's going to be. It would be if the z-coordinate was 0, but it's not. It's 1, so we have an extra step now. What we want to do now is from the origin, draw a line that leads to that intersection. So that will look like this. And now using that line, we want to draw a line parallel to that from the z value of our z-coordinate, which is 1. All right, so from our z-coordinate of 1, we're going to draw a line parallel to that line we just drew from the origin to the intersection of these two lines. So that will look something like this. All right, and now what we do to plot our point is draw a line straight up from our intersection here to this line, and wherever they intersect, which is right here, that's where our point H is located. Okay, so I hope that process makes sense. You just need to make sure that you use parallel lines, and you should be able to plot any point in 3 dimensions. All right, and so with that, that is it for this lesson. But if you do want to see some more example problems of working within the 3-dimensional coordinate system, feel free to check out my examples video that's linked here on the screen. If you have any questions, feel free to leave those in the comments. But if you don't have any questions, this is all I had for now, so I will see you next time.